Okay, hi everyone, welcome back to this video series for Introduction to Firewalls, Complex Protocols. In this chapter, you have encountered a number of protocols that use a single port. Keep in mind that some protocols, such as file transfer protocol, use more than one port. When you configure a firewall for those ports, you have to make decisions about how the firewall will handle multiple connections that are part of the same conversation. FTP, File Transfer Protocol, is a protocol that is used to transfer files. Most operating systems include a simple FTP client program, and many more capable FTP programs are available. Most server operating systems also include an FTP application. FTP is used to transfer files from a server to a server. Unfortunately, FTP is a moderately complex protocol, and FTP server listens on TCP port 21 for incoming connections. When a client establishes a connection on this port, it can do either of the following: tell the server which client port it expects the actual data of the file transfer to arrive on, in case in which case the server uses TCP port 20 to send data. Ask the server which port on the server that the client should connect to in order to initiate the data transfer. Protocols. Most of the protocols that comprise TCP are defined in one or more RFCs, requests for comment. RFCs are the primary specifications for the internet. They dictate how things should work. Some RFCs deal with very technical aspects of one or more protocols. Others are only informational and may recommend certain practices. Proposing RFCs and giving feedback on any RFC that someone else proposed is an open process. You can find out more about this process as well as search for RFCs at the website of the RFC editor at www.rfceditor.org, how a request is processed. Now that you know how the TCP suite of protocol works, put all that knowledge together and see how a request from a web page is processed from beginning to end. When you type www.wiley.com in your web browser, the following process takes place. 1. Your computer sees the request and sends out a query to a DNS server to determine the IP address of the web server. 2. The DNS server, possibly after contacting other DNS servers for assistance, returns the IP address 208.215.179.146 to the client computer. 3. Because you specified HTTP as the protocol on the URL, your computer tries to establish a connection to TCP port 80 on the web server. 4. Your computer uses its own IP address and subnet mask to determine that the web server is not on the same network segment. It forwards a packet that is addressed to port 80 on the computer with the IP address of 208.215.179.146 to the next router. 5. Routers on the internet pass the packet along until it reaches the web server. 6. After the web server receives the client's package, it responds to the client. Several packets are exchanged at this point to establish some TCP communications parameters, such as sequence numbers for packets. The resulting packet or packets originate from port 80 on the web server and are addressed to the same port from which the request originated. So you can see here, this is a picture here of a Cisco ASA firewall, within a network environment. So chapter 3, understanding firewall basics. When you connect your computer or your computer network to the internet, you are connecting it to millions of other computers, people who may be trying to get to the private data on your computer network, may be using some of those computers to keep unwanted intruders off your computer network. You should install and configure a firewall to separate the untrusted outside world from the trusted inside computer network. The firewall should inspect all network traffic and decide which traffic should be allowed to pass and which traffic should be blocked. In order for all this to work, you have to tell the firewall what is acceptable network traffic by specifying policy rules. Every firewall has different methods of specifying what traffic is allowed to pass, and every firewall has different inspection possibilities. However, the basics of most firewalls are the same. In this chapter, you explore the basics of firewalls, including a filtering strategy, packet filters, network address translation, NAT, and application proxies. What firewalls do. The term firewall doesn't accurately describe its function. A real firewall is a barrier to prevent fires from spreading from one room or building to another. A real firewall blocks fires completely. On the other hand, the firewalls discussed in this book should inspect all fires and let some pass through while blocking others. Sure, the internet is hot, but who came up with this term? A term that more accurately describes the function of the internet firewall products is doorman. The firewall is the security guard that sits behind a desk near the front entrance of a large office building and screens everybody who wants to come inside. Depending on the type of office, the guard may also screen or inspect people who are leaving the building. Many basic concepts of an internet firewall can be well described by using the doorman example. We'll use doorman Sam, a hard-working security guard at corporate headquarters of the fictitious law firm Legal Inc. to illustrate many of the firewall basics. Basic functions of a firewall. If you ask several people what constitutes a firewall, you are bound to receive several different answers. Different firewall vendors use the term with different definitions. In its simplest form, a firewall is any device or software product sitting between your network and the internet that blocks some network traffic. However, most people agree that a true firewall should have at least the following 4 basic functions. Packet filtering. The headers of all network packets going through the firewall are inspected. The firewall makes an explicit decision to allow or block each packet. Network address translation. The outside world sees only the outside world sees only one or more outside IP addresses of the firewall. The internal network can use any address in the private IP address range. Source and destination addresses in network packets are automatically changed or translated back and forth by the firewall. Application proxy. The firewall is capable of inspecting more than just the header of the network packets. This capability requires the firewall to understand the specific application protocols, monitoring and logging. Even with a solid set of rules, logging what happens at the firewall is important. Doing so can help you to analyze a possible security breach later and gives feedback on the performance and actual filtering done by the firewall. Because firewalls are a single point of entry for any network traffic entering or leaving your internal network, the firewall is an excellent location to perform additional security risks. Many firewalls support the following advanced functions. Data caching. Because the same data or the contents of the web of the same website may pass the firewall repeatedly in response to requests from different users. The firewall can cache that data and answer more quickly without getting the data anew from an actual website every time. Content filtering. Firewalls may be used to restrict access to certain inappropriate websites based on URLs, keywords, or content type. Video streams, for example, executable email attachments. Intrusion detection. Certain patterns of network traffic may indicate an intrusion attempt in progress. Instead of just blocking the suspicious network packets, the firewall may take active steps to further limit the attempt, for example, by disallowing the sender IP address altogether or alerting an administrator. Load balancing. From a security standpoint, a single point of entry is good, but from an availability standpoint, the single point of entry may lead to a single point of failure as well. Most firewalls allow the incoming and outgoing network requests to be distributed among two or more cooperating firewalls. What firewalls can't do. In a way, trying to protect a building is not much different from trying to protect a computer network. Both the building and the network contain employees who are trying to get their work done without interference or hindrance from security measures, yet most people realize the necessity of the security personnel and abide by the security rules. Similarly, users on the network should also understand that installing modems, bringing in virus-infected diskettes, or opening and executing email attachments of unknown origin may jeopardize security measures. Security threats that a firewall can't protect you from are inside attack. Users on the internal network have already passed the firewall. The firewall can do nothing to stop internal network snooping or intrusion attempts from within. Other security measures, such as configuring restricted permissions on workstations and servers and enabling the auditing of network access, should be implemented to protect against these kinds of attacks, although you can deploy firewalls between your corporate servers and your internal users as well. Social engineering. This is the term used to describe attacks in which hackers obtain information by calling employees and pretending to be a colleague at the front desk, a member of the security staff, or just somebody from the firm doing routine checks. This person asks for privileged information such as server names, IP addresses, or passwords. Employees should be aware of these tactics and know that certain information should never be given. Viruses and Trojan horse programs. Firewalls attempt to scan for viruses in all network traffic, but these wicked programs change constantly, distinguishing between acceptable email attachments and malicious content continues to be a problem for computer users. Good precautions should be taken to prevent the spread of viruses and to minimize the damage that a virus can do. Trojan horse programs are perhaps even harder to spot because they don't attempt to spread to other files or computers like their virus sisters. A very small Trojan horse program that is run once by an unsuspecting user can open a backdoor to his computer. A good example of this kind of damage that these programs can do is a Trojan horse program that sends out collected keystrokes as password prompts once a week. Poorly trained firewall administrators. The firewall doesn't know what is acceptable and what is not unless an administrator tells it. Competent firewall administrators should correctly specify which network traffic should be blocked. Most firewalls, however, can easily be confused by fragmented IP packets and should be explicitly configured to handle such fragments. Global strategy. Allow all or deny all. The two major possibilities are allow all strategy, allow all network packets except those that are explicitly denied. Deny all strategy denies all network packets except those that are explicitly allowed. If you use the allow all strategy, you have a list of every possible method that someone can use to intrude on your network and then come up with the rules to block related network traffic. Doing so results in a lot of rules, and even when you are bound to miss one, two, or several methods can be used to exploit your network, not to mention that your list of deny rules would not include newly discovered methods of or services that allow an intruder to enter your network. This is akin to doorman Sam locking only the ground floor windows that were previously used for illegal entrance into the building. Clearly, this is not a safe approach. The deny all approach is much easier to administer. No traffic is allowed except for a small number of explicitly defined protocols and services. The deny all approach has two advantages. You have to maintain only a small list of allowed network traffic rules. The smaller the list, the easier it is for you to verify that the configuration of the firewall is correct. You don't have to constantly add new rules to exclude newly discovered problems. Normally, the firewall policy that you want to express with firewall rules may be a combination of both deny all and allow all ingredients. The following firewall policy listing illustrates this point. In this example, the policy specifies what content network users can access on the internet. 1. Deny network traffic to all IP ports. 2. Accept allow network traffic on port 80 HTTP. 3. Accept from all HTTP traffic. Deny HTTP video content. 4. Accept allow HTTP video content for members of the trainers group. 5. Accept deny trainers to download HTTP video content at night. Notice that this firewall policy listing swings between deny all accept and allow all accept. When expressing which network traffic should be allowed or blocked, this listing serves only as an example to give you an idea of how deny all, allow all strategy works. Actual firewall rules for the same example on a firewall that defaults to deny all may look like the rules shown in the table 3.1. Port content users time action. Port 80, accept video all, always allow. Port 80 video trainers, they allow. If we express the same rules on a firewall that could be configured to use the allow all approach, the rules from the sample firewall policy may look like the rules shown in table 3.2. So all ports except 80 all always deny. Port 80 video accept trainers always deny. Port 80 video trainers night deny. Notice how much more complex the allow all strategy rules in table 3.2 are in comparison to the deny all strategy rules in table 3.1. An administrator needs to create firewall rules to implement a firewall policy. Many theories exist on what is the most intuitive way to represent a list of rules. Many firewalls use a combination of the following 3 techniques to process firewall rules in order. The firewall rules are processed top to bottom. The rules that match the current IP packet is used. The remaining rules in the list are not considered. The administrator should take care when specifying the correct order of the rules. An incorrect order can have drastically different results. Deny first. Firewall rules that explicitly deny certain packets are processed first. A matching rule blocks the current IP packet. If no deny rule matches, the allow rules are processed next. Best fit. The firewall uses its own methods to determine the order in which a list of firewall rules is processed, which actually means going from detailed rules to general rules. So I'm going to leave it here this evening for this video. If you like listening, please consider like, sharing and subscribing. Thank you.